Simply your vector formula, that is under root p1 square plus p2 square plus 2 p1 p2 into cos theta, whatever it is given. We did 2 good questions from this. Okay, 3 we did it. Now, class, electric potential, we'll do it in the next chapter, but there's a relationship between electric field and electric potential. So that part we'll be covering in the second chapter. Once you will do that portion in the regular class, I think on by tomorrow you have your class, there we'll complete, then in the next class we'll try to discuss it. So when we're talking about the electric field due to a dipole, electric field due to a dipole. So electric field's formula on the axial line and the equatorial line. This is what we have seen. So we know that across the axial line, this is 2 kp1 by r cube, and E across equatorial is minus kp by r cube. That way I'm writing it as kp by r cube. All right. Now, if the dipole is given, which is not just P, this has some value. So see, how will we solve it? So this is important. Just pay a little attention. Let's make it in the form of a graph. Let's see graphically. Let's say this is present. Think everything in terms of this graph now. Okay, this is the graph. A baseline, just to have a baseline, we have this. Now, let's say there's a dipole present across here. This is the dipole P. Now, this dipole has its components. Let's say this dipole has its components. Let's say this is one component, which is P cos theta. And here you have one more component that will be P sin theta. Let's say this is theta. Then this component will be P cos theta when you resolve it. So the first step that we did was here resolution of vectors. Resolution of vectors. So this was P cos theta, this is P cos theta. Now, I am not asking you a point here that you can say this is the axial line and you can use this formula. I'm not asking you a point here exactly, which is perpendicular to this P. If this is the point, see, this is the equatorial, this is the axial. These 2 points are not given to you. Otherwise, direct formula, you know how to apply them. I am giving you a point at a little angle from this dipole. Let's say at the axis of this P cos theta, here we are getting the resultant electric field at this point. So this is not axial, this is not your equatorial. So what is this? This is the electric field due to a general point. See, in your potential chapter, you will have potential due to a general point. There we'll see that. But electric field due to a general point is not included in your syllabus, in CBSE syllabus. So, but this comes in the exam. So you should know electric field due to a general point, that is making what angle? An angle theta. So you take the component of the dipole moment that is along there. Now see, once you have this, so electric field which is present, once you have this component here with you, let's say this here this is your final electric field that you need to calculate. So you will resolve this also further. Okay, if this is E, this is P cos theta along this direction, here along the same side, you will get your E P cos theta. And in the perpendicular direction and direction opposite to that of dipole, you will take the equatorial one, that is E P sin theta. And then you will take the net value of these two. Let's say this is going to some E net. This is the net electric field which is present. And this, take this angle as some phi. Okay, this is what is there, what all things are there. Phi doesn't mean the angle at which electric field is inclined. Phi means the net angle for the whole electric field when you are solving the components of the electric. Now, when we're talking about EP cos theta, let's just modify our electric field due to this P cos theta, EP cos theta. This is 2K, and now instead of P, we'll have P cos theta included. right? Divided by r cube. Similarly, electric field due to P sine theta. This is not getting multiplied. I hope you know. This is just a reference that this is due to the P cos theta and due to P sine theta. This is P cos theta. EP sine theta is Kp sine theta by r cube. Now, when you are calculating the net electric field, see both the electric fields, the formula for the net electric field will come out to be electric field due to a general point, or let me write it a little better, due to a dipole at any general point. So this will be electric field is, see, Kp by r cube will be there as it is. Kp by r cube is still here, like you had your electric fields formula. Some things will be additional. You have to multiply this with under root 1 plus 3 cos square theta. This is the formula for electric field due to a general point. Now this has a derivation, and derivation is from this only. EP cos theta, EP sine theta. You add, you calculate the net electric field, and with the whole derivation, you will find out things common and apply the identity. You will get this as the net electric field due to any general point. Now you can put any value for it and get the values for your equatorial and axial. See, if you have cos theta as 0 degree, cos 0 is 1. 1 into 3 is 3. 3 plus 1, 4. Root 4 is 2. So you're getting 2 kp by r cube. So from this, you already have your axial and equatorial. Now see, for equatorial, theta is 90 degree. Cos 90 0, root 1 is 1 kp by r cube. So from this formula, you can get your axial and equatorial back. This is a general formula. Just remember this formula, and with the help of it, you will be able to get your axial and equatorial field, electric field due to these points back. Let me write it separately here only. You have from here, if you put the value of axial as theta as 0 degree, you will get the value back. And for equatorial, put the value of theta as 90 degree. You will get your original equations back, which you have already studied. Okay, this is how you write. One more thing, if tan phi is asked, suppose what's the angle that the net electric field makes with the electric field's component? What was this phi? This phi was, see, phi was like, this was one electric field. Let's say E due to P cos theta. One electric field was here, that was EP due to EP sin theta, and we were getting a net electric field over here, and this angle was phi. You can be asked to calculate the value of this phi. See, this phi is different, theta is different. Theta is the angle that the dipole is subtending at the origin. That is the whole angle that is present. Okay, full complete angle with which we began our resolution of vectors. This is different. This is the net angle. This is like beta in your superposition principle or your vectors, the way you write tan beta's formula. So this is also similar to that. You are going to use it with the help of tan. Tan phi will be your E P sine theta component divided by E P cos theta component. So when you take their ratios, this is also equal to sine theta by 2 cos theta. So sine theta by 2 cos theta. So that can lead to a relation tan phi is equal to tan theta by 2. So this is one more relation. If you have the value of theta, the angle by which the dipole is making on the electric field, on the baseline, right? If you want to get the angle where your point is, whether it's a general angle, equatorial, axial. If you have a general angle theta, you have this phi, and you want to find its relation. So don't waste time how to get their relation using your geometry. No, just half it. Just divide it by 2. In potential also, you get a formula Kp cos theta by r square, but that's there in your school syllabus also, CBSE's board exam also. So there you will see its derivation also in detail. But electric field due to a general point can come in the exam. Is it clear?
Yes, ma'am.
And Jasleen, what about you? Understood this? Any doubts if you have from any of the paths? Okay. Write it from here. One more thing, class, please start making a habit of opening the videos in the class. Okay, meetings are already on the focus mode. If there is any specific issue in any class, just tell me in advance in that particular class. Okay, please write it. And if you still have any difficulties with this, because this can be a little confusing, so just let me know in advance. Just a second, just a second. The screen is actually, I have restarted it because it was hanging very much. Okay, class, these kinds of questions also come at a distance of 5 meters from the dipole. The minimum electric field's value is E naught. Find the maximum electric field's value at a distance of 5 meters and find the maximum electric field at a distance of 10 meters. So second part you will tell me, first part I'll tell you. See, when the electric field is maximum, remember one thing here, there's a small concept. Whenever the electric field is maximum, it is referring to the equatorial. Okay, this is this is due to the axial line. And if the electric field is minimum, this is due to the electric field of the equatorial. So now when it is saying electric field minimum is this, minimum is given this. So it means, you know, your Kp by R cube. This is your minimum Kp by R cube. This is equal to E naught. Okay, this is equal to your E naught. So you can say Kp by R cube is E naught. So Kp by, what is R in the first part? When you're talking about the first part, R is 5 meter. So 5 cube is given as E naught. Or you can simply say from here Kp is equal to 5 cube into E naught. Next, if this is the relation, now see. For the maximum electric field, final electric field at a distance of 5 meters from this, we will calculate, this is 5 meter in terms of E naught, we have got it. Now for the electric field maximum that we have to get, it will be 2 Kp by R cube, that is 5 cube. Now 2 Kp can be written as E naught into 5 to the power 3 divided by 5 to the power 3. This gets cancelled and electric field maximum becomes twice of E naught. You can simply take the ratio also, you will get the same answer with the ratio as well. Okay, so this is 2 times E naught. Is the first part clear? How have we calculated it? Ibrahim, Justine, both of you?
Yes, ma'am. Yes.
Okay. Write it second part's answer, both of you. Type me in the chat box. Yes, class, try this second part and tell me what's the answer coming. In the chat box, just type your answers. See how we'll solve the second part. Look, for the E maximum, you have the formula as 2kp by r cube. Now the radius r is given as 10. So this will become 10 cube. 2kp by r cube. Right? Now your kp's value is what? 5 to the power 3 E naught divided by 10 to the power 3. Now how will you solve this further? See, 2 into 5 to the power 3 E naught can be written as it is. Now 10, how can you write 10? In terms of a simpler number. 10 can be written as 5 into 2. So 10 cube will be, when we have 10 cube, it will be 5 into 2 whole cube, means 5 cube separately into 2 cube separately. This is what you will get. So when you will divide it by 2 cube into 5 cube, right? 2 cube into 5 cube. So what are we left with? See, this gets cancelled. 2 and 2 will get cancelled. So 4 will be left. So answer will be E naught by 4. Basically, in this, from this question, I want you to remember that the maximum electric field present is due to which line, axial or equatorial. Your minimum is due to equatorial, maximum electric field is due to axial line. So this is one thing that you have to remember. Write the second part, then we'll do a very good question that is based from your general angle. Please write this first. Yes, look, when we have maximum electric field, we have the formula of the axial line, that is 2kp by r cube. Now r for the second part is given as 10. So I've written it as 2kp by 10 to the power cube. 10 cube basically. Now 2kp, I am calculating it from the above part which we have already solved. From here we have the value of kp as 5 cube into E naught. So this will be 5 cube into E naught divided by 10 to the power 3. So when you divide it, you will get the ratio as E naught by 4. Because see, 5 cube and this 5 cube from the denominator will get cancelled. And you will be only left with 2 cube. Is that clear now? Why did we write it? Because the formula is 2kp by r cube. And r is given as 10. And from the first part, we have written the value of the E naught interval. All right, write it. Yes, class, think of any way how we can solve this question. You have a dipole moment given. Electric field is asked at this point. So is it axial, equatorial? What do you think? Just give some ideas how we should begin this. See class, this is a general point. This is not on equatorial, this is not on axial or any other point. So when you have the position vector, see this can be put as 0 I cap minus 3 j cap plus 4 k cap. Ibrahim, tell me what's the magnitude of the distance r?
R will be root of 1 square plus minus 2 square plus 2 square.
1 from where 1?
1 I cap, yeah.
But I cap is 0. There is no I cap. So no coefficient of it. Okay. This magnitude will...
Oh, okay. Okay, I
Yes.
thought that dipole. I'm sorry.
No, see, this is your vectors. This is the coordinate given 0, comma minus 3, comma 4. So when you're taking the position vector, you will make it as minus 3 j cap plus 4. So yes, the method is right. 3 square plus 4 square, which is equal to 5. This is the value of R. Now, remember, for electric field at any angle, I have discussed with you that electric field is Kp by R cube 1 plus 3 cos square theta. This is the formula of electric field at any angle. Right? This is the formula of it. It means we need cos theta. So class, what do you think? Jesslyn, you tell me. Do you think cross product will give you the angle or dot product will give you the angle? A better angle, direct angle with the help of magnitude, which is given better? By cross product or by dot product? Yeah, Jesslyn. Whenever you have to calculate angle, what you should start with? See, it will be dot product because you have AB cos theta. Yes, Jesslyn, correct. Dot product. Your answer is right. It is dot product. See, when you are multiplying two quantities, let's say we have the dipole and I'm just multiplying it with the vector. This is not giving me something proper. You have not studied what is P dot R. This is just a vector P with a vector R and that's it. Even if you take the dot products, this will be magnitude of P, magnitude of R into cos theta. So at least from here, you will be able to get the value of what is theta, that is the angle. So this will be C. P dot R. What is the dipole given? I cap minus J cap something, na? I cap minus 2 J cap plus 2 K cap. Your position vector is here in this is minus 3 J cap plus 4 K cap. Your dipole moment is I cap minus 2 J cap plus 2 K cap. So this is the position vector and this is the dipole moment. So now if I take both of it, not square, dot product of both of it. P dot R is P into R into cos theta. So from here, cos theta will be equal to, this is P vector dot R vector divided by P, magnitude of P multiplied to magnitude of the radius vector. From here, you are going to calculate the angle. See, this is very important step for your rest of the calculations also. You will just get the values of the vectors and you'll have to relate it with angle, and sometimes the angle will not be given like this directly. So you need to write it with the help of dot product. Okay, now let's see. Let's see how we can solve this. So when you're multiplying these two, I has nothing to be written with. But see, minus 2 into minus 3. Let's first write P dot R. P dot R. So see, I has nothing. So this is 0. Now minus 3 into minus 2 is plus 6. And plus 4 into 2 is plus 8. So you have 6 plus 8 into 10 to the power minus 16. No, minus 6. In the question, it has given us minus 6. Yeah. See, into 10 to the power minus 6 is present. So we are calculating into 10 to the power minus 6. And position vector, right? And they both we have multiplied it, both of these, right? P into R was 0 plus 6 plus 8. That was 6 plus 8, which we can write it as 14 into 10 to the power minus 6. So P dot R has been solved. Now P into R means magnitude of both of these vectors that are present. R's magnitude 5 we have calculated. Magnitude of this is also required. P. What are the values? 1 is 2, 2 and 1. So this also is magnitude of this is these are the vectors. Just the magnitude will be 1 square plus 2 square plus 2 square. Like this. Look, 1 square plus 2 square plus 2 square. This is giving you what? This is giving you the magnitude of the vector. Right? Magnitude, because you require the magnitude right now. So this will be 4 plus 4, 8, 9, that is 3. Right? So this is root 9, which is equal to 3. Now let's write what is cos theta. Cos theta is P dot R, which is 14 into 10 to the power minus 6. What is P into this individual R? This is 3. Oh, this will be 3 into 10 to the power minus 6 because this is from the dipole into this. R is the 5. So 10 to the power minus 6 gets cancelled. This becomes 14 divided by 15. So you have the value of cos theta as 14 by 15. Now in your actual formula, which is K first, KP. K is 9 into 10 to the power 9. P is 3 into 10 to the power minus 6. KP by R cube. R cube will be 5 cube. 1, let's write it here only. Let's multiply it in one step only. This is 1 plus 3 cos square theta. Means you have to write 14 by 15 whole square. So this is just the square of it, 14 by 15. So see, what did we have now? 1 plus 3 cos square theta. So this is giving you the value of electric. A big lengthy question, but had lots of concepts in it. Lots of concepts. Is this point clear to both of you, Ibrahim, Jaseen? You've understood this? All right, then. Write it from here. Class completed. Ibrahim, Jasleen, have you written it till here?
That's not.
Okay, Jasleen, what about you? Done? Okay, so this completes with the whole concept of electric field, and it is due to a dipole. Also practice these questions, class. These are very good questions that are taken from your previous years and different books. Usually the questions from this has recently not come, but just practice the questions and do your assignment. We'll discuss it in the next class. I'll give you homework from the previous year's questions. Okay, let's meet on Tuesday now, and we'll start with different concepts of forces due to a charge. Though let's come towards that part. Okay, force and torque and all. Let's see that. Torque though is the same. Okay, class. Thank you then. Okay, bye.